What's the most destructive weather you can imagine? Hurricanes, blizzards, droughts. No doubt, these are all capable of large-scale devastation. But there is another kind of weather not on that list, one we've only really begun to understand in the last couple of centuries, and which we don't tend to think about nearly enough. Battery solid, because its destructive force could go way beyond the local impact of floods and high winds. Instead, think trillions of dollars in damage and untold havoc around the globe. This is the enormous power of space weather. Down here on Earth, most weather is caused by the heat and light reaching us from the sun. But heat and light are far from the only things that giant nuclear fusion reactor in the sky is sending our way. For a start, there are more dangerous kinds of radiation, plus a continuous stream of highly charged particles known as solar wind. And sometimes, we get phenomena called coronal mass ejections, or CMEs, giant coiling magnetic fields carrying a dense plasma of energetic particles, tens of thousands of kilometers wide. All told, the sun is basically a huge ball of chaos, belching out a colorful variety of destructive forces in all directions. 24/7. But, as alarming as that sounds, it isn't generally something we need to worry about. For one thing, most of these emissions simply fly off into empty space. And even when they do reach the Earth, we're surprisingly well protected. When it comes to solar, wind, and sea, our main defense is the magnetosphere, an expansive magnetic field created by the movement of the Earth's molten core, which acts as a kind of force field. The clash between these energetic particles and our magnetic shield can be seen in the form of auroras, the northern and southern lights. Normally, these only occur near the poles, but during really powerful solar blasts, they've been seen thousands of kilometers closer to the equator. While such tropical light shows are rare, their appearance is a sign that our defensive shield is getting overwhelmed, and that's when the trouble starts. When enough of these energetic particles make it through our defenses and into Earth's atmosphere, the result is a geomagnetic storm. These have been happening for eons, but in the past, we had no way of noticing them. While normal storms have rain, thunder, and lightning, geomagnetic storms just create fluctuating magnetic fields, which are considerably less dramatic. That is, until they pass through a coil of metal. When that happens, the result is an electrical current power surge. And as our use of electricity has grown over the past couple of centuries, this has started to represent a major problem. In 1859, one of the biggest geomagnetic storms on record, known as the Carrington event, sparked fires in telegraph stations. In 1989, a much smaller storm knocked out power for millions of Canadians for 9 hours and shut down the Toronto Stock Exchange. Losing power for hours in freezing conditions is bad enough, but that was before the internet became so central to our way of life. Today, the fallout could be much, much worse. Imagine national power grids going down, taking essential infrastructure like water and sanitation with them, not to mention hospitals, transportation, banks, and central government, and all of it taking weeks, months, or even years to rebuild. While this is a worst-case scenario, consequences even a fraction as severe would make this a threat worth taking very seriously. So, how do we prevent these disastrous geomagnetic storms? Well, the bad news is, we can't. Much like regular storms, all we can really do is prepare as best we can. That means implementing contingency plans and backup systems, hardening our power grids, and rerouting flights away from danger. Massive undertaking at the best of times. But to do any of that, we first need to see the storm coming, and that's the really tricky part. The most powerful CMEs can reach Earth in under a day, which isn't much notice. This means we need constant, real-time data to act quickly and effectively. And while some satellites do exist specifically for this purpose, most are already past their retirement age, which is a little unnerving given that the stakes are increasing all the time. 150 years ago, the dangers posed by geomagnetic storms were almost non-existent. Today, they represent a serious risk to the technology we all depend on. The irony is that the same technology vulnerable to these freak space weather events is also our best defense against them. Data gathered by satellites and analyzed by AI programs is crucial for helping us understand and predict these storms. But over the next 150 years, as our reliance on technology increases and we continue to venture out into the solar system, beyond the protective shield of our magnetosphere, that understanding is only going to become more important. Without it, we risk being caught off guard by the kind of perfect solar storm that, sooner or later, is going to happen. Thanks for watching. If you found this interesting, consider hitting that subscribe button and ringing the bell so you don't miss our next video. See you next time.